Hello everyone, my name is MD Imrul Srifat. My ID is 24581972 from Computer Networking and Cybersecurity Department from American International University of Bangladesh. Today, I will be presenting experiment number 7, Digital Logic and Logic Design Laboratory, different types of flip-flops. First, let's look at what this experiment aims to achieve. Our first objective is to understand the basic operation of sequential logic circuits. Second, we will study the characteristics of D flip-flop and JK flip-flop. Third, we will learn about H triggered asynchronous input, especially preset and clear, and finally we will verify the truth table of the flip-flop using IC 7474 and IC 7476. Then, before driving into flip-flop, we need to understand the difference between combinational and sequential logic. In combinational logic, the output depends only on the current inputs. Example includes adders and multiplexers. In sequential logic, the output depends on both and the current inputs and the test states. Then, flip-flops are the more basic building blocks of sequential circuits. Counter resistors are all built using flip-flop. Now, let's talk about the flip-flop. Here D stands for data. Its function is simple. Where value is at the D input, when the clock's rising edge arrives, the value gets transferred to the output Q. The logic function is Q n plus 1 equals to D. This means the next state equal D. Its biggest advantage is that it eliminates the undefined or invalid state from SLHS. It is most commonly used in shift register and data storage application.
Assalamu alaikum everyone. My name is Fahim Shaharia. The flip-flop to table is always correct, and calculation is always correct. Looking at the two table, if the clock is low or high, but no rising edge occurs, the occur Q does not change. It holds its previous state. When a rising edge occurs and D equals 0, and then Q equals 0, which is called the reset state. When a rising edge occurs and D equals 1 and Q equal 1, which is called the set state. So the key takeaway is the output only changes at the rising edge. It stays stable at all other times. JK flip-flop is the slide 6 number. Next, let's move to the JK flip-flop. It is called the universal flip-flop because any other type of flip-flop can be built using it. It has two inputs, J, which sets the output, and K, which resets the output.
Now I will talk about the IC and apparatus part. Here is the hardware we used in this experiment. Number 1 IC is 7474, which is a dual D-type positive edge triggered flip-flop, and the second IC is 7476, which is a dual JK flip-flop with preset and clear inputs, a trainer board for power supply and connections, a connecting wires interconnect all the components. The next slide is timing diagram. The timing diagram shows how the output Q responds to the clock signal. The output only changes at the rising edge of the clock, even if the input changes between two clock pulses. The output stays stable until the next rising edge arrives. This is one of the key advantages of edge triggered flip-flop: predictable and stable behavior.
Now I will explain conclusion in this slide. We successfully verified the behavior of both D and JK flip-flop. We observed that sequential circuit require a clock signal for proper synchronization, and we gained a clear understanding of how many limits are applied in a practical digital logic design. Thank you, sir. Thank you for watching this video. I hope this presentation give you a clear understanding of flip-flop.
We are connecting 2, 3, 4, 5 and 16 with 5 volts and the 13 nong pin are grounded. Then this 1 number input pin of IC will connect in clock generator. The positive side of LED will be set on 15 number of pin and ground side will be set on common ground. Here is the final result of our project, which depend on D flip-flop.